So here we're going to do vertical asymptotes. So what vertical asymptotes are is that line that the function, the vertical line that the function, rational function crosses, gets close to but never crosses. So I'm just going to draw a shape. Sometimes you'll see some functions look like this, where it goes up like that, and it goes steeper and steeper on forever, and on the other side also does like this. And there's this invisible line right down the middle that the function doesn't cross, and that is called a vertical asymptote. So for your rational functions, the way we find these guys is when the denominator, let's change this to white. When denominator equals to 0, or the x values that make the denominator equals to 0. Let's be more specific. That cause denominator equals to 0. Okay. So all we have to do to find these guys is to find the x values that cause the denominator equals 0, and the way we do that is to set denominator equal to 0 and solve the equation. Alright, so we have an example over here. We have a rational function. So let's do exactly what we said here. We're going to find the vertical asymptote for this. Okay, so we have f of x equals 3 over x plus 3. Interesting. Okay, x was 3. And then, so to find the VAs, we just have to set our denominator. In this case, it is x plus 3. You just have to set this equal to 0. And then we solve the equation. So x plus 3 equals to 0, x equals to negative 3. So let's graph this. And we can actually see that we get our vertical asymptote at negative 3. Okay, so let's graph our function here. So we have 3 over x plus 3. And as you can see, we have a vertical asymptote there at x equals 2, negative 3. Right? Yeah. So our function gets close to it, but never crosses it. Same thing over here. So yeah, makes sense because if we substitute negative 3 into our function, we're going to get 3 over 0. And any number other than 0 divided by 0 is undefined, and that means that we're going to have a vertical asymptote there on our function right over there. So yeah, let's move on to our next example. Okay, so in this example, we're going to showcase why you would want to find holes first before you get your vertical asymptotes. Because sometimes it looks like you'll have 2 vertical asymptotes, but instead we're going to get a hole there. And you'll see why. So let's pretend that there are no holes here and get our vertical asymptotes like normal. So what we will do is we set our denominator equal to 0. Equals to 0. This is supposed to be a colon. Okay. And then when we factor this, we get 3x plus 2, x minus 4. Alright. So it seems like we have 2 vertical asymptotes here. But in this example, we actually don't have 2 vertical asymptotes. We actually only have 1. One of these guys is actually a hole. And we can actually prove this if we try to find the holes first. So we are going to do this on a separate area over here. So if you try to find holes first, what we'll get is this. Set the factor at the bottom. Alright, so if you remember from before, holes occur at the factors that we are able to cross out from the top and bottom. So since in this case, we can cross out the x minus 4 and the x minus 4 over here. That means that we will have a hole at 4. So our vertical asymptote, which we thought to be 4, which you got over here, is actually a hole. So this is why you want to do holes first. That way you can distinguish what factors in your bottom are holes versus vertical asymptotes. So yeah, if we continue on with this case, we get 1 over x plus 2. VA is at equals negative 2 over 3. And then the hole is at 4, no longer a vertical asymptote. Okay, so yeah, there you have it. Let's go to Desmos to confirm this. Okay, so let's graph this. We have x minus 4 all divided by 3x squared, well, 3x squared minus 10x minus 8. Alright, so as you can see here, we only have one x-intercept. We have it at negative 2 over 3, indicated by this black line. You can see our function gets close to it, doesn't cross it. So what happens at 4? So we kind of see, we have the hole over here. Nice. There we go. Confirmed. So yeah, you might be wondering, why is that the case? Because we're technically dividing by 0. If we substitute 4 into our function, we're going to get something divided by 0. And wouldn't that be a vertical asymptote? So that's not always the case. We only get vertical asymptotes when it's a number other than 0 divided by 0. So in this case, if we substitute 4 into our function, we get 0 over 0. And remember, for holes, if we get 0 over 0, we're going to get a hole. And otherwise, if it's like 1 divided by 0 or like 2 divided by 0, anything else divided by 0, we will get a vertical asymptote there. So yeah, that's why we want to get holes first before getting vertical asymptotes, just so that we can be clear about which is which. There'll be no confusion at the very end. So yeah, that's it.